Okay, let's move on to section 5. All right, so we're done with section 4. Let's move on to section 5. We learned all about nth roots in the last section. Today, we are going to talk about operations with radicals. Okay, so um, first off, you've seen this in Algebra 1. But the product property of radicals basically says the following. For, if you have real numbers A and B, and if the index n, is some number greater than 1, then if you have the nth root of AB, you can split that up. So you can do like nth root of A separately times nth root of B separately. So like do each one on its own sort of a thing. Okay, so we're going to talk about how to simplify fourth root of 32. Now, when the index is, a number other than 2, what you want to do is when you look at the factors, right, how many of each base is in that number, you want to group them by that number 4. So, for example, 32 we know is 2 times 16, which is 4 times 4. And that's 2, 2, 2, 2. Now, if the index is 4, that means we have to group these by 4. So this group of 4 2's comes out as a single 2. That other lonely 2 stays inside. So we have the fourth root of 2. Okay? So one group comes out as a single 2. One lonely one stays inside, and then the root just stays, right? If it's a fourth root, it stays a fourth root. So I always think of like the root or the radical as a jail, right? And then whoever can find the appropriate number of partners escapes the jail, and then those other lonely people, they stay inside. Okay? Okay. So here we go. Cube root of d to the 7. Okay, so d to the 7 means there are literally just 7 d's. Okay, and if I'm going to group them by 3's, I have one group, two groups. So those two groups of d's escape the prison. So we have d squared because two groups came out, and one lonely d is going to stay in there. So I have times the cube root of d, and that's the answer. All right, let me do one more and then I'll take a question. So here I have a square root. That means everything has to be grouped by 2's. Okay, so here we go. I'm going to do each one of them separately, the 12, the c's, and then the d's. So the 12, square root of 12, we know is 2 root 3. So the 2 comes out, and then this 3 stays in. Now, for the c's, I have c to the what? 6 divided by 2? 3. But now this is even, odd. So it takes absolute values. D. Okay, what about the D? I have 3 D's in here. I'm going to group them by 2's. One group comes out, one stays in. So in the end, that is my answer. So 2d c cubed root 3d. Now, you don't have to switch the order of the c and the d. I just did it like for cleanliness. Okay. No, right, but it was not even odd. It was even odd, so that's okay. Only if this is even, okay, does it come out. Okay, so for you to need the absolute values, the index has to be even. This exponent also has to be even, and it should come out as an odd exponent. So even, odd. You get it?
Yeah.
Yeah.
Do you have to take d to the power of 3 out? Like, is it wrong to leave it in the radical?
Yes, because there are 3 d's in there, and it's a square root. That means anytime you can group them by 2's, they can come out of the jail, right? since you have an excess, you have to take them out. And then I'll show you an easier way right now. Yeah.
For problem B, why did the D come out as D squared and not 2D?
Because it's D times D that came out. Each group that comes out is multiplied by each other.
But when you do it for whole numbers, you don't do it.
You do. Because if you have a 2 that comes out and then another 2 that comes out, it's 4.
Right, because that's 2.
No, it's, well, if you had 3s, it would be 3 times 3, 9.
Oh.
Yeah. Okay. So, okay, here we go. Cube root of 27, we know is 3. Now, okay, I have y to the 4. Okay, it was fine. Okay, the d to the 7, we wrote it all out. We had fun with it, but, it gets a little old. Okay, it really gets a little old. So here's what we're going to do. You know how, like, we were dividing that 4 by that 3 before? Okay, so here's what we're going to do. We're going to divide 4 by 3. That's going to give me a 1, remainder 1, correct? This is the number that comes out. This is the number that stays in. So here, y to the 1 will come out. And here I have a cube root. So 1y will stay in. Okay, let's do it for the z. I have z 7 over 3. 7 over 3 is 2 remainder 1. So 2 comes out, z squared, 1 stays in. And that's a much quicker way of doing what we did. So for example, if we were going to do that same thing with the d's here, 7 divided by 3, that would have been 2 remainder 1. You see how d squared comes out, 1 stays in. Okay? Yeah. Yeah, please you don't need to write that down. Okay. Now, quotient property is similar. If you have a square, if you have a root and you have a fraction under the radical, you split it, you do the numerator and denominator separately. Okay, but remember, we are not allowed to have roots in the denominator. This is what I was talking about with that one f inverse, right? Where you had like the square root of something over 2. Okay, so starting now, that's no longer going to be okay to leave it like that. So when you have this 1 over root b, you have to multiply top and bottom by root b over b, right? By this. So for example, if you have 5 over root x, you have to multiply the top and bottom by root x. So now I get 5 root x over x. So remember, whenever you have square root times square root, that comes out as a single x. Let's look at that a little bit more closely and see why that happens. If you have square root x times square root x, that's technically square root of x squared. I have 2 x's inside. They come out as a single x. Okay? Okay, now let's take a look at the bottom. Okay, the bottom, if I have a different root, an nth root, you have to multiply top and bottom now by n minus x. So nth root of b, n minus x. Okay, Miss Malikan, what the heck are you talking about, right? This just got very confusing. Well, no. I need to get rid of that root on the bottom, the radical on the bottom. So here's what I'm going to do. I'm going to multiply. If it's a 5th root, I still have to multiply by a 5th root. Now, check it out. If it's a 5th root, how many do I need to group by for them to come out? 5. I already have 1 4 in there. How many do I need to put in addition? 4 more. Okay? But, why don't we simplify that further? Yeah, I have 1 4, but can I simplify that further? 4 is made up of a simpler base of 2, right? 4 is 2 squared, correct? So now that makes it a little bit simpler because look, I need a total of 5 2's in here for them to come out. I already have 2. How many additional do I need? 3. right? So I'm going to multiply top and bottom by 5th root 2 cubed, and then 5th root 2 cubed. So you see this red 3 here? It's the index minus the exponent. 5 minus 2, n minus x, okay? So here on the bottom I have a 2, and in the top I have 3 5th root of 2 cubed. Okay? Okay, which 3 are you talking about? The red 3?
The one above the 2.
This, because there was already a 3 here from the beginning. This 3?
Yeah.
Well, okay, I have 2 2's in here. I need a total of 5, so I need to, if I have 2, I need to put in 3 more to make it 5.
But we still have to finish it to make it.
Correct. That's why we did that minus that. Okay, so in simpler form, this is 3 5th root of 8 over 2. Okay, let's do some other ones here. All right. Oh boy, what happened here? Okay. Oh my God. Okay, so I'm going to split this up. Cube root of y to the 8. I'm sorry. Square root of y to the 8, square root of 9x. Okay, what do I get on top? Y to the 4th. On the bottom, I get 3 root x. Okay, now the only issue I have here is the root x. So I multiply root x, so I get y to the 4 root x over 3 times what? X. Okay? Cool. All right. Cube root of 2 over cube root of. Now, the 9 can simplify to how many squared? 3 squared x. Okay, so now I have an issue here. I have to multiply top and bottom by cube root of something. Okay? 3 to the how many? 3 minus 2, 1. And then x to the how many? That number minus the exponent squared, 2. Okay? Yeah. So cube root of 3x squared. So now I have on the bottom 3x squared. And then in the numerator, I have cube root of 6x squared. Okay, questions? Here, how is this 3x squared? Okay, so if I combine these under the radical, I have cube root of, let's combine these. I have cube root of 3 squared times 3, 3 cubed, x times x squared, x cubed.
Yeah, just the x.
No, but the 3 also comes out.
No, but the x.
Oh my God, x, sorry. Oh my God, sorry, x. I'm so sorry, x. Okay. This? Okay, so you have cube root. Now you're going to multiply everything inside the 2 cube roots. 3 squared times 3 is 3 cubed. Oh, this is a 3. Sorry. Okay. All right. Yep.
Whenever you do the rationalizing the denominator where you subtract n minus x, is it always going to work out so you end up just getting no radical?
Yeah, that's why you kind of make it that way. Doing it n minus x.
If you
No.
always just have whatever.
Right.
Yeah.
Let's simplify radical expressions. So basically, a radical expression is simplified when the index is as small as possible. The radicand has no factors like that can come out. The radicand contains no fractions and no radicals appear in the denominator, okay? So, for example, in that so in that problem that we had, I forget exactly what it was, but remember we had f inverse of x. I'm just going to make something up. Suppose it was x minus 4 over 2, okay? I said it was okay to leave it like that on the quiz, but on the test, this is no longer going to be okay. So what would we do here? This would be the square root of x minus 4 over the square root of 2. Now, I would multiply top and bottom by root 2. So finally, I would have on the bottom just 2. And on the top, I multiply these out. So when I have a radical times a radical, I combine and multiply the insides. So it'll be radical 2 times x minus 4. Okay? And now this 2 is inside. This 2 is outside. You cannot cancel them anymore. So even though on the quiz I was okay with this, on the test I will not be okay with it. I will be okay with this. Now I know somebody's going to ask me, do I need to multiply it and make it 2x minus 8? I don't care. Okay. Let's move on. Okay. Here, all right. So I have a similar situation. I have 5 cube root of something times cube root of something else. Okay. So first what you want to do is if they're combined, we want to separate them. If they're separate, we want to combine them, okay? So here we have the cube root of 100 times 10 is 1,000, a cubed. So this is 5 times. Cube root of 1,000 is 10 because, you know, it's the number of zeros, right? 10 times 10 times 10. Times a. So finally, this is just 58. Okay? All right, here. This is 6 times 4, 24. And in the square root, I have 8 times 2, 16. C to the 4, d to the 8. This is 24 times 4, c squared, d to the 4, no need for absolute value. So I got 96c squared d to the 4. Fabulous. Okay, here we go. To simplify these, you have to make them into, like first you have to simplify each radical. So 4 root 8 will be 4 times 2 root 2. 3 root 50 will be 3 times 5 root 2, right? So this is 8 root 2 plus 15 root 2. And as long as these roots are identical, you can combine them and just combine the coefficients. So this is 23 root 2. Okay, here. This is 3 times, what's root 45? 3 root 5. Right, 9 and 5, so it's 3 root 5. Minus, okay, 5 times 80. So what's 80? It's 4 times 20, 4 root 5. What do you do if you can't just come up with them? The factor tree, okay? You do the factor tree, okay? All right. Plus 4 times root 20, so 4 times 2 root 5. Okay. All right, so what do we have here? 9 root 5 minus 20 root 5 plus 8 root 5. So negative 3 root 5. Okay? Questions? Okay. Here we go. Something like this, we're going to FOIL. Okay? So, first terms, 2 root 3 times 3, so the first terms will be 6 root 3, right? And then outer terms negative 2 root 3 times root 3. Inner terms, positive 3 times 3 root 5. And then the last terms, minus 3 root 5 times root 3. Okay. So 6 root 3 minus, how much is the red stuff here? Just 6. Good. Plus 9 root 5 minus 3 root 15. Okay, so now check. Can any of these be simplified further? No, this is it. This is done. We can't do anything else with this. And okay, you know what? So it looks a little unconventional. It's okay. All right, not everything has to like come together so neatly. Okay, let's go ahead and do the next one. Okay, so first terms is, oh, sorry, the first terms, I actually wanted to change colors too. So it's 49 times 2. Outer terms plus 21 root 6. Inner terms minus 21 root 6. Oh, wow. Outer terms minus 9 times 3. So this is 98. These two go away. Minus 27, 71. Okay, now, could we have known that from the beginning? Look at what I have here. I have 7 root 2 minus 3 root 3. 7 root 2 plus 3 root 3. Check this out. This is just a minus b, a plus b. So I could have just gotten away with square this one, put a minus in the middle, done. Right? That could have easily worked. Okay, but if you don't see it, it'll come out. Okay, take a look at this one. Okay, here I have an expression underneath. So I have to multiply top and bottom by the conjugate. Remember a complex conjugate? Well, now I need to do the conjugate of this. So if this is root 6 minus 5, what would be its conjugate? Root 6 plus 5. Multiply top and bottom by root 6 plus 5. Okay, and I'll do the longer way the first time. So in the numerator, I'm going to get 8 root 6 plus 40. Bottom, let's FOIL. So first terms, 6. Outer terms, what do we get? 6 root 5. Inner terms, minus 6 root 5. What about the last terms? Negative 25. Positive, negative 25. Okay? So finally, this is how much? 8 root 6 plus 40 over negative 19. And that's it. This is not a complex number. You don't have to simplify it. However, if all three of these numbers were able to be divisible by the same number, you should have done that. Okay. Now, here too, from now on, we're just going to do the shortcut. We're never going to do it like this again. So let's do the next one and then I'll take questions. So here, I'm going to multiply top and bottom by the conjugate of the denominator because it's the denominator that has an issue. Okay, so I do have to FOIL the numerator, right? Because they're different. So it's going to be 6 root 3 minus 24 minus 3 minus 4 root 3 plus 4 root 3. Okay, the denominator, it's going to be the first number squared minus the second number squared. Always, because it's a plus b, a minus b. So finally, here I have 6 root 3 plus 4 root 3 10 root 3 minus 27 over 3 minus 16 is how much? Negative 13. Okay. Now, that negative 13 is a little awkward. Okay, the negative in the bottom is a little awkward. Most of the time, we don't leave a denominator as a negative like that. It just looks wrong. Okay? Okay, so a couple of ways you will see this written to get rid of this negative here. One is you can write it like this. Okay? Or most probably, this negative is going to be distributed inside. So what do you get? Negative 10 root 3 plus 27. But then the positive one is always written first. So it'll be 27 minus 10 root 3 over 13. All of these are the same. But I'm telling you, it'll most probably be written with the positive number first. You don't have to, but like the book will never leave it like that. It will always be like this. Okay? All right. So here, oof, what the heck is happening here? All right. So let's do this one. What do I multiply top and bottom by? Right. All right. So let's FOIL the top. I get x root x minus x minus root x plus 1. Okay, there isn't much to simplify there. And then on the bottom, what do I get? X minus 1. That's it. Don't go canceling 1s and x's, and that's it. Next one. What do I multiply top and bottom by? Just root x squared minus 4. Why? Because this is one entire root, whereas the other ones were a root plus or minus a regular number. Okay? But this is just a regular old root. So if the whole thing is in the root, you just multiply it with the same thing. So we get x squared minus 4 on the bottom. And here I get x squared minus 4, all inside the root. And now, somebody's going to ask me, do we then have to factor out the x squared minus 4? You don't have to. Why? Because by factoring this out, we're not going to be able to cancel with anything. So that's it. Do not cancel these two. Okay? Because one is inside, one is outside. This guy's in prison, this guy's out of prison. We don't associate. Okay? All right, any questions? Fabulous. So on the test now, whenever you have a fraction under a root, you must rationalize the denominator. Okay? Question?
What is the difference